All right, guys, quite a bit of stuff today. Linear equations, functions, zeros, and applications. That's 4 things. We better hit it. First of all, just solving one variable equations. You should be pros at this by now, so I'm not going to spend a whole lot of time here. I'm going to show you a couple and just kind of move on. This one right here, the distributive property first. 2 times 5, 2 times 6 equals 8. Distributive again, it's a -3, so be careful with your signs. On the left-hand side, nothing to combine. Right-hand side, I can combine the 8 minus 6. That's supposed to be 3, and get 2. Now it's just a matter of combining sides. So I'm going to move the 3x over here. Sorry, the 6x over. Makes it a positive 3x plus 2, which leave 10 on that side. Move the 10 over the 2 over there with the 10. Gives me 8. Divide by 3. 8/3. And of course, always you can check your answer to a one variable equation just by plugging your answer back where you started. That should be 8/3. It's not very, my marker's not doing too good today. Okay, the second one is a bigger deal. I'm going to kind of rewrite this one in the way it would look in your book. 3/4 x minus 1 equals 7/5. Now, one piece of good news, when you have fractions in an equation, you're allowed to get rid of them, which is what I'm about to do right here. All you do is this. You find your LCD, least common denominator, which in this case is 20, and multiply everything in your equation by 20. And what happens is this. It gets rid of your fractions because 4 and the 20 cancel. Leaves 5 times the 3 on the top, which is 15. Don't forget the 1. 1 times 20 is 20. Then I'm going to do 5 goes into 20 4 times. Multiply that times the top. 4 times 7 is 28. Look what happened. One step, no more fractions. We're good to go. So to finish up, I'm moving the 20 over. I get 15x is 48. Divide both sides by 15, I get 48 over 15. Now, all I want to do is put that in lowest terms. Do we want to leave it improper? Just reduce it. 3 goes into both of those. 3 goes into 48 16 times. It goes into 15 5 times. And there it is. Words here, make sure you get this. If you see the word solution solve, find the x-intercepts, find the zeros of a function, all those words represent the same number or the same term and the same number. So don't get messed up with the words. And matter of fact, you can find solutions by graphing equations and looking what the x-intercepts are. You can also, well, on your calculator, zeros are how you find your x-intercepts. They're called zeros in your calculator because they're all called zeros. That's where the y coordinate is 0. That's why they're called zeros. So those 3 words all represent the same number or the same term. All right, so when it says find the zeros, here's what it means. Find out where y is 0. So all you do is you plug 0 in for your y, or f of x. It's function notation, so it'll be f of x, and just solve it. Move the 25 over, make it -25 is 5x, divide by 5, you get -5. Now the reason they call it a 0 is because if I plug it in that function, if I plug -5 in there, the f of x would equal 0. So that's why it's called a 0. It's also a solution. It's also where the x-intercept is. It's all that stuff. So let's do one more. Put 0 here. -2x plus 11. Move the 11 to the other side. You get -11. Divide by -2. Because they're both negative, you get a positive 11 halves. That's a half. And there you go. Again, that's called a 0. Also an x-intercept, also a solution. But the reason, again, it's called a 0 is because if you plug it in the function's value becomes 0, or the y is 0. Okay, some applications here. Bad news is we got about 3 more slides and they're all word problems, but hang in there. I'm trying to show you one of everything that you're going to see tomorrow. This one says there are about 232,000 words in the Japanese language. This is, let's say this is 19% more than the number of words in the Russian language. How many words are there in the Russian language? So all I did here is I took the Japanese words and I'm adding 19% of that by multiplying their total by 19%. So I'm going to take my calculator. It just squeaked. And I'm going to go to 19% of 232,000 and I got 44,080. So I have 44,080 plus the original 232,000. Need to add those together, and I get 276,080 words in the Russian language. So that one's not too bad. When you do a percent, when you're adding a percent, a couple of ways you can do that. That's one way, and I'll show you a little quicker way tomorrow in class. But this is the way when I was teaching this in another class already this year. That's how they told me they did it. So that will work every single time. Distance, you should have seen the distance formula before in algebra. Distance is rate times time. Rate is speed, how fast are you going, times how long you're going that speed, and that tells you how much distance you're covering. Let's read this one. Delta Airlines fleet includes B737-800s, each with a cruising speed of 531 miles per hour. That's what I'm talking about. And Saab 340Bs, each with a cruising speed of 290 miles per hour. Suppose that a Saab 340B takes off and travels at its cruising speed. 1 hour later, a B737-800 takes off and follows the same route, traveling at its cruising speed. How long will it take before the faster one, the B737, overtakes the Saab 340? So what I did down here is I just set up their formulas. I did the Saab right here. Their distance is 290 times how long they've been gone. The 737, you do rate times time. Their speed is 531. Now, I did T minus 1 because they were gone. Their time is 1 hour less than the Saab. So their distances, for one to overtake the other one, means their distances are the same. So their two Ds are the same. So the distance for the Saab is this. That's the distance for the Saab. The distance for the B737 is this. So I'm just going to set them equal to each other because their distances are the same. So on the right-hand side, I'm going to distribute the 531 like this. I'm going to move the 531 over with the 290. So I'm going to subtract that. Now we get negative 241. T is now it's 531. So to get my time, I'm just going to divide both sides by 241. So I get 531 divided by 241. And I get like 2.2 hours. And that's hours because they were going miles per hour. So it's going to take a little over 2 hours to catch up. It only left an hour later. All right, simple interest. The interest formula is I equals PRT. Every time I say that, I think about the Michael Jackson song, but it's called PYT. But it stands for principal times rate times time. If you're not sure what those means, the principal is how much you borrow. Rate is what your interest rate is, and time, of course, is how long you've had it. So let's read about Demi here. It says Demi's 2 student loans total $12,000. Hope you don't ever have to get those. One loan is at 5% simple interest, and the other is at 8% simple interest. After 1 year, Demi owes $750 in interest. That's why I hope you don't get them. What is the amount of each loan? Well, the first one, her first loan, I just did the formula. I equals PRT. I do not know how much she borrowed. That's what the question's asking me. I do know it was at 5%, and she's had it for 1 year. The second loan is at 8%, had it for 1 year. Now, this is the hardest part. It's 12,000 minus P. Now, if she borrowed 12,000 altogether, and she got this much, she got P for the first one. To find out how much she borrowed on the other loan, you do 12,000 minus that number. For example, let's say she borrowed 4,000 in her first loan. That means she would get 8,000 on her second loan because that adds up to be 12, and because 12 minus 4 is 8. She borrowed 10 on her first loan. That means she borrowed 2 on her second because 12 minus 10 is 2. So works just like that. Here's what we know about her total interest. Her total interest is $750, which means if you add up her two interests, that means she's going to owe that much. So I'm going to set these up. Her first one is this much, 0.05p. Her second one is 0.08 times 12,000 minus P. Now I just kind of rearrange those a little bit. I'm not worried about the ones because 1 times anything is just itself. And it says altogether she owes 750. So together her two interests have to be 750. So I'm going to do distributive right here with the 0.08. 0.08 times 12,000, which is 960, minus 0.08p, and that's 750. So I can combine my p's, which would give me negative 0.03p. I'm also going to go ahead and move that 960 over to the other side and get negative 210. I'm going to divide that and see what I get. 210 divided by negative 0.03, and I get 7,000. So that means one of her loans is $7,000, and her other loan is $5,000 because the other one was 12,000 minus that. So those are the amounts she borrowed in her two loans. One more slide. All right. Metro Taxi charges a $2.50 pickup fee and a $2 per mile traveled fee. Grayson's cab fare from the airport to his hotel is $32.50. How many miles did you travel in a cab? Well, there's not really a formula for this one as much as it's really, to be honest, it's slope-intercept form in a way. It's rate of change. He's going to pay $2 per mile. We don't know how many miles he went. That's what the question's asking us for. So you do $2 times how many miles he went. He's going to pay $250 just to be picked up, which is, that's part of it. And altogether, his total is $32.50. So the equation kind of sets up itself. by just reading the problem. Hopefully that makes sense to you. And it's real simple to solve. I'm just going to move the 250 to the other side. That would make that 30. Divide by 2. That's 15. So that means he's going to go, oh yeah, I used M for miles. So his trip is 15 miles. It cost him $32.50 to go 15 miles to his hotels. Hopefully those made some sense. They're not really, really difficult word problems. You need to make sure you have those formulas with you. Those will really help because you're just going to use those over and over again. And the rest of it's just kind of simple equations and those words. Make sure you know x-intercept, zeros, solutions, all mean the same thing. So I'll see you tomorrow. We'll work on it like we always do. Look forward to seeing you.